Saxon Algebra 1, Lesson 91. We have two topics today. The first one involves number lines. And I want to show you what's new in an example. I don't want to just explain it. Graph the solution to this inequality. Remember that when we graph inequalities, the domain tells us what the picture is going to look like. If it's integers, we're putting dots on the exact numbers because we only include the exact numbers in our solution. When it's the reals, that means we want to include all the little fractions and decimals that show up between the numbers, the main numbers on the number line. So this is when we draw the arrows. So I always write under my domain either arrows or dots, and that reminds me what my picture should look like. We'll come back to that later. Here's our inequality that we need to graph. And as you can see, we have a problem. We have this big, ugly minus sign sitting in front of our x. I don't like that. I don't want it there. So we have to get rid of it. And we have two ways that we can do that. We can either multiply both sides by -1 or divide both sides by -1. Either will work. I'm going to do it both ways in different examples, but in this one, I'm going to multiply both sides by -1. I have to do the both to keep it in balance, but this is going to allow this to change. But this comes with a big fat caveat. Because, see, this turns to positive, right? This will turn to a -2. But here's the rule. Give you a second to finish writing it. When we multiply or divide an inequality by a negative number, which is what I did right there, we must flip the inequality. And what I encourage you to do is think of it as picking it up and flipping it over like a pancake in a griddle. This has nothing to do with the trichotomy axiom. This has nothing to do with negated inequalities. That's a different subject. When we're multiplying or dividing by a negative, we just flip it like a pancake. And I show that by that little marker. John does not use that, but I do. That's my reminder to flip it. So when we finish, it's going to look like that. Aha! That changes things considerably, doesn't it? Now we go to graph. This is puffy cloud of knowledge business, though. And notice that it's only for multiplying or dividing by a minus number, a negative number. It has nothing to do with subtraction. Sometimes that's confusing because you see the minus sign and you think that's the problem. No, it's the multiplying or dividing by a minus. Subtraction is just fine. So let's graph this. Ready? I prefer the domain of the real numbers because our graphs can be so much easier. -2. Plop that down on my arrow. I can see that I want to include -2 in my solution because it's equals. So I put a circle and then I color it in. And then I'm going to go this way. That's my answer. Right? Let's do another one. We have two topics today. I don't know if I mentioned that. I think it helps to know ahead of time when a second topic is going to come. I don't like surprises. You probably don't either. There's the inequality that we need to graph. Our domain equals the integers. It's okay to substitute these so you don't have to write it all out, but I do want you to write the domain down on your homework page, and I want you to write under it dots or arrows. This is integers. That means we only want the main numbers, not any fractions or decimals. Okay, we'll get to that later. Let's fix this. We need to get rid of this 4. Subtracting does not flip our sign, right? Subtraction is fine. Now we need to get rid of this minus sign. This time I'll divide by -1. And that means we have to flip that like a pancake. So now this becomes positive, so we have x. We flip the inequality, and then this gets the minus sign. Draw our solution. Integers means we need to put a little more information on our graph. They're kind of a pain. So let's go 1, 2, 3, 4. We'll put a 0 in. And I'll tell you what the method is to my madness. With integers, we don't have the arrow to show motion, so it's a little bit less satisfying to graph. We want to show values of x that are equal, -2. I thought it was +2. -1, -2. I'm going to squish in a -3. That is a very weird looking graph, but it'll work. I'm not going to scratch it out and start over. I'm just going to fix it. And I encourage you to do that too. Just add and edit these. You don't have to be perfect. We want to include -2, and then we want values that are greater. Now, I didn't need to show so much of this, but I need to show at least one point that isn't included so that you can see which ones are included. If I was doing this better, what I would do is I would go -4, -3, -2, -1, 0, and then I would put the dots here, here, and here. It helps to see what isn't included. I didn't need to show that many dots. I like this one better. And I consider this part of the answer too, right? Okay, let's do one more. Just one more? Just one more. Before we switch topics. Sorry, we're not done. Graph the solution, minus. Domain equals the reals. Again, you can abbreviate this, but be sure to write the domain down and immediately write down dots or arrows. This is reals, that means it's arrow. Okay. I guess I better subtract 4 from both sides. Again, that doesn't change anything. -3x is less than or equal to 9. Now, I've got to get rid of this -3. I'll divide by it. That flips this, because we're dividing by a negative number. X is greater than or equal to -3. Agreed? And this is the reals. So here's a quick little sketch. All I have to do is put in the -3. I circle it. Do I want to color that in? Yes, because that's an equal sign. And then I want the values greater than. So here is a nice, neat little answer package. Beautiful, right? Keep your number lines as simple as you can. Okay, let's change gears. Now we're going to talk about spheres. Oh, look, I made a poem. Let's change gears and talk about spheres. What is a sphere? A sphere is, you can think of it as a 3D circle, a three-dimensional circle, or a ball. That's a sphere, right? It has 3 dimensions to it. We're going to use formulas to talk about the volume and the surface area of a sphere. I'm sorry. It's kind of big and ugly, isn't it? These are not my favorite. I think they're just kind of annoying formulas to work with. They're not hard, they're just kind of annoying. They have pi and they have cubes and they have that icky fraction. So let's just look at the first example. Find the volume of a sphere whose radius is 3 centimeters. Okay, well, all we have to do is just plug it in. By the way, if you looked in the book, you would see all kinds of crazy diagrams and pictures and calculations. What John is trying to do is he's trying to help you understand the logic of how these formulas are derived. I'm going out on a limb and I'm going to say at this point, you don't really care how it's derived. Just show me how to do the homework problems, right? Don't give me any extra information. So that's what I'm doing. I'm just showing you how to use it. If you wake up in the middle of the night in a cold sweat because you really want to know how John came up with this, then go to page 380 and you can read all about the derivation of that formula, but I'm not going to tell you. Okay, so now how do we use it? Well, the volume of our sphere equals 4 over 3 times pi times 3 cubed. We have to put the parentheses around the 3 so that we see that the cube just goes to that. All right, so then it becomes this, 3 cubed we know is 27, right? And the 3 and the 27 can cancel. This will be a 9, and that will be a 1. That's gone. So now, all we have to do is multiply 4 times 9, that's 36, times 3.14. See that we canceled the 3 against that and simplified this as much as possible. And now I do 3.14 times 36. Go ahead and do this multiplication yourself. No, this is right. This is the correct answer. Okay, so multiplying 3.14, which is pi, times 36, which was all the other numbers smooshed together, gives us this as our final answer. That's the volume of this sphere that we have. And volume is always a cube because it's 3-dimensional, right? Okay, so that shows you using this formula is fairly straightforward. It's just a little bit of a messy calculation, but it's fun. Now we're going to, and that's all we're going to say about the volume of a sphere. There's the formula. There's an example of a problem where we use it. Now we're going to change gears, and for our last problem, we're going to talk about the surface area of a sphere. A surface area is just the outside of it, right? It's a calculation of area. It's that magic wrapping paper calculation, right, of how we would cover it. But it only measures the outside. It doesn't measure the volume, which that volume measures the inside, right? It measures all 3 dimensions. Surface area is just the outside. So we have a different formula for that, but it's equally creepy. The good news is we're not going to use these formulas much. So I want you to see them. I want you to be aware of them. I want you to write them in your notebook where you keep all your formulas. But this is not an ongoing thing. Again, I'm just giving you the formula and I'm showing you how to use it. I'm not going to show you how it's derived. This is on page 381. So if you wake up screaming in the night because you don't know how that formula came to be, you can read about it and find out. Just like the other example, find the surface area of a sphere whose radius is 4. And it's meters. This time I'll just jot that down. All we do is plug in and solve. So surface area equals 4 times pi times 4 squared. 4 squared we know is 16. 16 times 4 we know is 64. So I'm cleaning up all those outside numbers, right? Everything else, I'm cleaning all that up. Then we'll do this last multiplication. 3.14 times 64. And let's see what we get. There's my final answer. Hopefully your multiplication worked out. You got the same as me. So again, just like with the volume calculation, once you have the formula and the radius, it's just plugging in and simplifying. It's not much of anything new, but those formulas are new and kind of creepy if you're with me. But don't worry, just feel comfortable enough with them that you can do these problems and it's no big deal. Okay, guess what? That's the end of lesson 91. Thank you, goodbye.